Hey everyone, I got one more parent function video to get through here. We have 3 more parent functions to do. So we're going to round out our 12, and we're going to be able to graph these last 3 parent functions of our 12. Finally, thank goodness. Alright, so domain, range, extrema, asymptotes, even, odd, symmetry, continuity, and boundedness are still all in play. Let's take a look at what's going on. So the first one we're going to do here is absolute value. Remember, absolute value has the bars. F of x equals the absolute value of x. Now, you guys probably know absolute does one thing, right? It makes everything positive. So basically, anything that's negative turns into a positive number. This is actually defined as a piecewise function. You leave it alone if x is positive or equal to 0. And if it's less than 0, you take the opposite. Check it out. Let me show you what I mean. Like if you're doing f of negative 3, so absolute value of negative 3, what you would do is you would say, well, I don't want it to be negative, I want it to be positive. So what do? You throw another negative in front of it. Negative, negative 3, which makes it a positive 3. So undoing a negative is as easy as putting one in front of it. Piecewise defined function. You're going to see that in the next video as well. So the graph of it, well, x, we know, just looks like that, right? And negative x looks like that. So you've probably seen this function before. It's a v. Okay, everyone, I once had a book that talked about doing the algebra aerobics, and they had people doing this with their hands, doing the V up in the air, and the lane change, they made like a hula, like a squiggle. I don't know. Anyway, so domain of this guy, all real numbers. You can take the absolute value of anything you want. The range, only positives, which makes sense because its absolute value only gives you out positive numbers. Continuous everywhere on its domain, increasing from 0 to infinity, decreasing from negative infinity to 0. I guess we should have parentheses on those. Symmetry, this is an even function. Check it out. You could reflect it over the y-axis, and it's even. Makes sense to me. If you plug in negative x, absolute value of negative x is equal to the same thing as if you did absolute value of x by itself, because negative and positive both plot you up to the same value. And so that means that is f of x, which means that it's even. Bounded below, we have a minimum at x equals 0. Asymptotes, nope. End behavior, as x goes to positive infinity, the function values are going up. And as x goes to negative infinity, the function values are going up as well. Left up, right up. Nice. All right. This one's kind of a weird one. It's called the greatest integer function. So the greatest integer function is f of x equals int x, int x. Int stands for integer. The way this function works, some people also call it the floor function. You'll see it written like this sometimes with like a floor underneath it. So the way it works is if you take a number like 5.2, why it's called the greatest integer function is because I want the greatest integer. Remember, the integers are the z's, they're the whole numbers, less than or equal to that number. So that's 5. 5 is the greatest integer less than or equal to 5.2. Let's try another one. Let's try like 4.9. Let's do 4.99 just for kicks. Why not? Living on the edge. 4.99 would give us 4. We're just rounding down. Now this gets a little bit weird. What would f of negative 3 be? Well, f of negative 3 is negative 3. Sorry, I should have made it more interesting. F of negative 3.5, let's say. If you think about a number line, here's 0, here's negative 3.5. The greatest integer less than or equal to that is going to be over here. That's negative 4. Interesting. So we're rounding down, and on the negative side, that's actually going to give you more negative numbers. The way this looks, think about it. If I plug in 0, I get 0, because 0 is the greatest integer less than or equal to 0. Plug in 0.5, I get 0. Plug in 1, I jump up to 1. Interesting. So from 1 to 2, I'm at 1. From 2 to 3, I'm at 2. From 3 to 4, I'm at 4. You can see why some people call this the step function. Because it looks like steps. If you plug in like negative 0.5, that's going to bring us down to negative 1. And down to negative 2, negative 3. Cool. So we have this step function every time we go dot to hole, dot to hole, dot to hole. Domain, all real numbers. You can do this for anything you want. Range, interesting. I only get out the integers. My favorite range, because it's the one time you get to use like an integer for a range. Continuous, well, what I read here is it is discontinuous on all integers. Every integer you hit, 1, 2, 3, that's where you have those jump discontinuities. Increasing, really never, right? It's tempting to say it's increasing always, but all of these are flat, so it's never really going uphill. Also never decreasing. Symmetry, let's think about that. It's definitely not even. Is it odd? I don't think so, because if you rotate this guy right here around the axis, it would have to map to exactly the same spot on the other side. So we don't have any symmetry. Not bounded, no extrema, no asymptotes. End behavior is interesting. As x gets bigger, what's happening to the y values? They're getting bigger. So limit as x approaches infinity of f of x would be positive infinity. And as x approaches negative infinity of f of x is negative infinity. Right, up, left, down. That's all there is to it. All right, one more, and then we are done. Yay! So, last one is called Logistic. This is a really cool function. It's kind of difficult to grasp. We're going to talk a lot about it in Chapter 3. So, logistic function is f of x equals 1 over 1 plus e to the negative x. Let's see if we can unpack what this is going to look like if we graph it. Excuse me. So, if we think about this, let's first of all think about what would happen if we plug in 0. So, f of 0, this is a good strategy. If you never know what a graph's going to look like, just plug in some points and see what happens. So, f of 0, that's going to be 1 over 1 plus e to the 0. E to the 0 is 1, so that's 1 half. So, at 0, I'm at 1 half. Let's say that's right about there. Now, as x gets really big, so as x becomes very, very positive, e to the negative, like 10,000, remember when we did e to the x? This is going to be a very small number. Very small number. The bigger x gets, e to the negative x is going to have less and less influence. What does that mean? That means this number is slowly turning into 0, getting very, very small. So as we go further and further to the right, we're approaching a value of 1. We'll never get there, but we'll get close. As we go to negative infinity, so if we have like e to the negative 10,000, those negatives cancel. Now this is very influential. So this e to the negative x becomes very big. We have 1 over a big number. We're approaching 0. So this function actually ends up looking like is like this. Ooh, 2 horizontal asymptotes. That's kind of cool. So we come from the bottom, we come up to the top. You may have seen this for things like population control. Like if you have a lake, then you have a bunch of fish in the lake. They'll grow quickly initially, but eventually hit what they call the carrying capacity. Logistic functions are super useful in the real world. It's really cool. Plug in whatever you want. Range 0 to 1. You can change the 1s here and stuff to make this bigger and smaller, but for this parent function exactly, we're only between 0 and 1. Continuous everywhere. Increasing everywhere. Never decreasing. Symmetry. Remember, it has to be around this point, so we have no symmetry. It has to be around 0, 0 if it's going to spin. You could say that it has rotational symmetry around the point 0, 1 half, but that'd be kind of weird. It's not even or odd. Bounded is bounded, both below and above. Remember, we just say it's bounded when that happens. Extrema, nope. Asymptotes, we have 2 horizontal asymptotes at y equals 0 and y equals 1. End behavior, limit as x approaches positive infinity of f of x is equal to 1. Those function values are climbing up to 1. And the limit as x approaches negative infinity of that function, as we go to the left, those functions are dropping down to 0. And that, ladies and gentlemen, is all of our parent functions. Thank goodness it's all done. I love you guys. That's why I'm here. Have an excellent day.